Welcome to the Intelligent Autonomous Driving System by Asia Technology Industry ATI. So we have modified the micro EV car into fully autonomous mode. So we can use this car in both manual as well as in autonomous mode. So in order to turn this vehicle in from manual to autonomous mode, so we have these two buttons. So this one is for auto acceleration and this one is for auto brake system. So both acceleration and braking system will be autonomous. So once we have switched the vehicle to the autonomous mode, we need to localize the vehicle in the real world. So for that we use multi-GNSS, which is multi-global navigation satellite systems, to localize the vehicle. For that we use dual antenna receiver satellite system. So in case of dual antenna, we get the precise vector from the front antenna, and from the back antenna we get the precise positioning. So let me show you the multi-GNSS receivers that we are using. We are using Michelin multi-GNSS receivers. In this Michelin receiver, we have only one antenna system. So that's why we are using currently two receivers for calculating the vector as well as the positioning of the vehicle very precisely. So in this case, the Michelin, they broadcast the Madoka PPP data directly from the satellite. So we don't need to connect to the any data service center which provide the correction data. For this one, the correction data is directly transmitted from the satellite to the receiver. So that's the current system does not use RTK, but we use PPP into that. So all the computations that we are doing and then other sensors that we are using, all this computation is done in this industrial CPU that we are using. And then we can display currently you can see the display on this, and then we are getting this time the PPP, and the accuracy is around 15 to 16 centimeter in case of 2D, and in 3D it's around 20 centimeter. All this system is being broadcasted in real time via 4G network, but in future we will be using 5G once it's available. And then we have the Ellipse camera from Tokyo Carrion. We are using this one. We have installed two cameras in the car. One is for the external environment of the vehicle to monitor, and another one is for the internal environment of the vehicle, wherein the passenger are being monitored. And this is for the safety purpose, because if there is some obstruction or something in the system is breakdown, so the vehicle will stop, and the server we will get the information in the server, and the vehicle will be monitored from the server room. The Ellipse system that we have in the back, so these are the two cameras. This is the front camera, which will record the external view of the external environment of the vehicle, and this is for the internal environment of the vehicle. So both cases in real time the data is being sent to the server. Also here we have a display wherein we can change any type of display we want to see. We can see the map, we can see the interior and exterior cameras, and other information we want to display about the autonomous system that will be displayed on here. If there is some error or some other breakdown of the autonomous system, that also will be displayed in here for the passengers that are inside the car. So we have the laser scanner also installed in the car. This is for the detection of any obstacle that comes in front of the car, whether it's the pedestrian or whether it's some other car. So whenever there is some other car and then we have to lane change or something, so this will help us in lane change and then come back to the path where the car is following. And also if there is some pedestrian walking in, so it will detect, and the system will automatically tell the autonomous to stop until there is free way for the car. So in case if there is a breakdown in the autonomous system, so we have this VR 360-degree camera which will monitor the environment of the vehicle 360 and broadcast in real time to the server. So from the server room we can directly drive this car without any assistance. So the visualization will be done from the 360-degree camera, and in case of traffic issues or in case of breakdown of the autonomous system, so the autonomous vehicle will not be stuck at that place, but it will reach to the destination where it has been selected. So this was about the intelligent autonomous driving system that we have developed in a single-seater micro EV car. Now we are developing the same system in the four-seater micro EV car. So this is all about the intelligent driving system in ATI. Thank you very much.